Hello, this video is regarding to the seventh assignment of the SPDA practical of the computer 2019 course. So this is my blog kathinirmalwordpress.com. Here you have the tab DSPDL. When you go into the student corner, you can find out the instructor manual for seventh assignment, that is text analysis. We have to perform the text analysis. So here we have to perform the practical in two parts. The first part is to extract the sample document, and you have to apply the document pre-processing method like tokenization, POS tagging, stop word removal, stemming, and lemmatization. And in second part, we have to create the representation of document by calculating the term frequency and inverse document frequency parameter. So first, let me explain you basic of text analysis, or why we need the text. This concept we need before starting the practical. First one is what text analysis. So the text analysis is frequently used in day-to-day conversation, like we are going to give the movie reviews, then we are going to chat, email, message, and all of this action will lead to the substantial amount of unstructured text. And now we want to produce this particular text. So here we have what natural language processing is used. It is one of the component of text mining that is used to identify the sentiment, finding entities in the sentences. So in Python, we have the NLTK, that is Natural Language Toolkit, that will provide easy to use interfaces and lexical resources like WordNet. From that, we can find out the various methods for tokenization and the stop word and then lemmatization and all. So we'll start with the what do you mean by tokenization. This practical we are going to perform using Python, and that too we are going to have the implementation in the Google Colab laboratory. So let me open the Google Doc first. So when you go into the new in Google, right, you have the option of Google Colab. If you are using first time, so you have to integrate the Google Colab, else it is available in your drive. It means it is attached with your drive. So this is the Google Colab. Now if I will rename my document, that is text analytics. So let me start with the first one is what we need to perform the tokenization. So now tokenization is the very first step of the text analytics. Here it is the process of breaking down the paragraph into the smaller chunks. That chunks may be word or maybe sentences. So here we have two type of the tokenization. One is sentence tokenization and one is the word tokenization. So let me write down the code for both the tokenization, that is word also and the this sentence also. So now every particular step to perform the Python code is given in my manual. So when you go over here, you have the first is what we have two algorithm for tokenization, tagging, stop removal, stemming, and lemmatization. So first we'll start with the tokenization. So before, if I want to utilize the package of NLTK, as we have known, NLTK is the Natural Language Toolkit. We have to download some of the packages that we need for the implementation of this practical. So first we are going to download this particular packages, that is NLTK packages. So we have downloaded this packages. Now next is what we have to initialize the text. As an input, we are going to give one particular text. So this is the text that I want to give for the my input. Okay, I need to give the this one also. I need to upload the library, import the library. So which library I need to import, that is NLTK. So this library I should import first, and then I'm going to download the packages. So here I am going to write down NLTK and then I'm going to download the packages. So I have downloaded these packages. Now next one is what? I want to perform the tokenization. So from NLTK, from NLTK, I should import the from tokenization. So I have the tokenization. I should import sentence tokenization. So I have the method import. I have the sentence tokenization. So SENT, and then I have the tokenization. You can press control space. So it will be suggesting you. Clear? So this is sentence tokenization. Now my text. If my tokenized text, I want to declare one variable that is for tokenized text, and that I want to send tokenize is my function. So I will write down send tokenization. In that, I'm going to pass the text that I want to convert it into tokenize. So before that, I need the text. In text, it should be stored. Text should be stored the values that I want to tokenize. So suppose I'm giving the value this token. I'm giving this particular sentences. So this I had given. So this is text. Now text is converted into tokenized text. And then if I want to print tokenized text, so just I should write down tokenized, and then I should write text. So it will convert it into the small chunks. You can observe. First is what? First tokenization is the first step of text analytics, and this is the second sentence. So it is divided. Now same, if I want to go for the word tokenization. So for word tokenization, same. I need only from tokenization, instead of sentence, I need to pass what? Word. So I'm writing word tokenization. Then again, then same. What I need is, again I need is again I needed tokenized text. Now I need what? Tokenized word. I need what? Tokenized word. So it is, and here I need to find out what? Tokenized word. And this is will be stored into word tokenized. This function I should call. And then I'm going to print the tokenized text. My tokenized text is stored in the word file. So this is what. Now you can observe, see this one. Every particular sentence is divided into small chunk words, and it is consider white space. White space will be considered as a break of line. So this all regarding what the your tokenization. Now next, if you can observe here, we have the punching mark, punctuation marks. So if we don't need this punctuation marks, and here we have the is, the, in, of, this statement. So these statements are known as the stop words. So now if I want to remove these stop words or punctuation mark from the NLTK library. So I have the ready-made functions for that. So suppose I want to remove the stop words. First, I need to remove what? My stop words. So to remove the stop words, first we will see that what do you mean by stop words? So in the NLTK, your document will be known as the corpus. So in this particular corpus, NLTK.corpus, CORPUS. Now we are going to import. We need to import what? We need to import English. English stop words. So we are going to give stop words. So we have the stop words. Now, which are the stop words? So I'm going to store this particular stop words into one particular variable, that is stop words equal to, then I have the set. This is the set. I want to convert it into the set. So I have the stop words function dot. Now I need to convert it into what? Whoever the words of English. Here we have the French also, then we have the Japanese also, but we should go with what? English. So here we need to define words of the English only. So we are going to write down English. So English stop words. So we have the import code. First we need to import stop words. Done. So these stop words have been done, and now we are going to print this particular stop words. So this has been done. So now we are going to print what? This stop words. So this stop words will be printed. Done. So after printing this particular statement, now you can observe why, you, have, yourself, who, what. This all are what? The stop words of English. Now I want to remove stop words from my particular word or tokenized word. So how I'm going to remove is, so suppose I'm going to take one particular text. So my text is how to remove stop words with NLTK library. My NLTK is library. Now I need to what? I need to remove this. So in Python, I can say. So first step is what? First step is what? I need to remove tokenized word also, and I need to remove punctuation marks also. So when I want to remove the punctuation mark, so this I can do using the regular expression of the Python. So I can write import RE, that is a regular expression, import RE. Now in the next line, I'm going to write down stop. I'm going to write down the tokens that I have generated. So very first thing is what? I need to remove what? My punctuation mark. So text equal to RE dot sub. What I need to keep only A to Z. Other than A to Z will be converted as what? Will be converted as a white space. So I will convert A to Z, or if I can have the capital A to Z. So this will be treated as what? As normal character A to Z. If other than this, if I have something other than this, so if I have something other than this, that will be considered as a what? That will be considered as a white space. And now this particular white text will be converted into the text part. So this is my text, and this is what? Text. Done. So in this way we have what? We can write down this part. Syntax error, I think so. So we are going to rewrite it. That is what? 1 second. It is the syntax error. We have this syntax. It should be like this. So now if we are going to print our statement text, so you can observe that it does not have any punctuation marks. Now, when we are going to see this particular things here, everything has the small letters. So when I want to delete my stop words and punctuation mark from my text, so first thing is what? I need to convert this particular thing into the lowercase. So how we are going to convert into the lowercase? Suppose I have the tokens variable. In that word tokenize, what I have used in the word tokenize, then this word tokenize, I am passing what? Text dot lower. Means I am converting my tokens into the lower, and that I am passing into what? Word tokenize. So my sentence will be divided into the words, and then particular word will be stored into what? Your tokens. Now if I'm going to print the tokens, so it will generate it the every particular. See now how to remove stop in. Done. So this is what is. Now I want to remove what? Lower is that. Now I want to remove what? My stop words. Now to remove this stop words for every particular word. So for W in tokens, one by one I am going to match my tokens with the stop words. So if word not in stop words, if it is not present in stop words, we have already stored all particular stop words into this variable stop words. If it is not into the stop word, then we are going to consider into the filtered text. अगर वो नहीं होगा उसमें, then only we are going to consider into the filtered text. Then we are going to append that particular filtered text with that particular word W. Clear? So filter text. Now filter text is what we are going to declare one particular array that is filtered text, and that filter text is what we can say it is one string, array of string. So we have what filtered text, and that particular filtered text we are going to run over here. So here I have written filtered text and then append W. So I have appended. Now I'm going to run it. Now, if I want to print the filtered text, what I want to print is this my tokens. Now I need to print what filtered text. So if I'm going to print the filtered text, remove stop words and LTK library Python. How is removed? To is removed, then width will be removed, then NLTK library, it is in the in will be removed. So in this way, we can remove the stop word. So this is the example how we can remove the stop word. After that, we have to perform what stemming. Now, here we have two concepts. One is stemming and one is the lemmatization. So stemming is a normalization technique where list of tokenized words are converted into the root words. Suppose I have the finish, fished, finishing, so everything will be converted into the word fish. If I have the argued, arguing, that also converted into the argue. And in lemmatization, you are going to lemma of the word depending. It means what? Here we are going to consider the morphologic analysis of the word. So let me give you the like studies. Studies will be converted into study. So we see some example of stemming and lemmatization and how both the lemming and stemmatization will be different. That also we are going to see. So first we will see the stemming. So for stemming, we need to do what? For stemming, we need to do from again NLTK, from NLTK dot stem dot we are going to import some porter stemmer. Here we have the width package porter stemmer, which will be useful what for your stemming and lemmatization. So now we have the suppose e words. Now this e words is the collection of the words that I want to pass. Suppose I want to pass some words that is wait. I want to pass. Then I want to pass waiting. Then I want to pass waiting like waiting. If I need to pass something like waited. So now if I'm going to do what the PS. PS equal to post timer. So I'm going to write as the post timer. So this will be PS. But now for every particular word W in E words, I need to find out what? I need to find out the root words. So my root words will be so my root words will be my root words for every particular. So I will pass PS dot stem function, and here I will pass my words. My words are present in words. It will take one by one word and it will convert it into the water timer, and then we have the root of the word will be returned. And then I'm going to print what this I have done. Let me check for the errors. If unpositional arguments e words. Okay, we should pass W over here, not the E words, because E words we have stored into W. So we should pass W. PS dot stem W. Root words equal to root words equal to ps dot stem, and then we have w. It need one position argument word. Root words. P dot words. Then we put a stemmer rating. So let me check for the errors. Let me copy from here also. I have the top code for this. It is a small mistake, I think so. So we can take from this. See, for every particular thing, what we have the what? Weight. Weighted, weighting, weightage, everything will be converted into what? Your weight. Now, if I want to print every particular type, so weight, 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 weight ka weight, weighting of weight, weighted of weight, weights ka weight. And this way we have what? The tokenization of stemming. Now, if I read the lemmatization, so here I am going to write down what? Same. My code will be same. Like, and we are going to import stemmelization. Then function we are going to, with the function we are going to select. Then text equal to studying Christ car. Then tokenization equal to NLTK, the tokenized text. My data is stored into the text. And then every particular word, I'm going to write down what? This. So my format is what? Word net dot lemonizer and then word. So if I'm going to print it, lemma for studies is study. Lemma for studying is study. Cries is cry. Everything is given. Here we have what? Studying. Then we have cry. Done. So in this way we have what? Cry. In this we have feminization. Now the what is difference between this one and this one? So now if I'm going to perform the uh, stemming of this particular word, so if I'm going to pass this particular word over here, that is studying, then I have these studies, then I have the cries, and then I have the cry. So now you can observe the difference. So instead of studies, what is written? Study, cry. So there is no any lexical meaning checking present in your stemming. So lemmonization is the more effective than the stemming. So this covered our lemma size. Now we are going to convert the next one, that is POS tag. Now POS tag means what? POS tag will give you the information about every particular word of your statement. Like if I want, it is adverb, it is verb, it is mm, pronoun, it is noun. So it will be given by the POS tagging, positional tagging. So now we are going to do import. Then we have the NLTK. From this NLTK, we are going to find from NLTK. Now we have the NLTK dot tokenize. Now we have the next import word and tokenize. Done. So import word tokenize. Now we are going to find out. Suppose I have the data. So my data equal to the pink sweater. The pink sweater fits her perfectly. So now it will give, if I want to do what? I want to do the words equal to, I need to tokenize my word, and then I need to what? PO. So first I need to do what? I want to tokenize my word. So for tokenize, I will write data, my words will be tokenized. Now after tokenizing, I'm going to write for word in words. What I need to check is for word in word, I need to print, I need to print the PO, I need to print the POS. So that will be NLTK dot POS. Now we are going to find TAG tag, and then the word we are going to pass. So what we have, that is present in the word. So this is the, now we are going to print. So the DT, pink is noun, sweater is noun, fits it's noun, prepositions, then verb, adverb. This RB means adverb, prepositions, every particular thing is given by this. So these are the first step of our practical. That is what we need to perform. In first practical, we need to perform all these particular operations in our data. In next video, we are going to see that how we are going to find out the term frequency and inverse frequency from this particular data set.